All right, so this is 6-3 notes. We are proving quadrilaterals are parallelograms, and our first theorem says if both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram, and here is the picture that goes with that. And then Damien, who's going to read 6-9 for us?
If an angle of a quadrilateral is supplementary to both of its consecutive angles, then it is a parallelogram.
All right, so let's draw the picture that goes with 6-9. So let's throw down your parallelogram. My parallelogram is awesome. Okay. So if I have angle A and angle B, and if the two angles are supplementary, then it is a parallelogram. Okay, and then Clayton's going to read 6-10. So if both pairs of opposite sides are congruent, then it's a parallelogram. Opposite angles. Okay. So let's see if I can master drawing a parallelogram. So that means if like A and C, so if angle A is congruent to angle C, and angle B is congruent to angle D. Sorry, A, B, C, and D. Alrighty, next who's going to read the next one? Jack C, do this. So if the diagonals bisect each other, so we've got, I'll make the diagonals in a different color, diagonal here, and a diagonal here. So put your congruent mark to the right or the left of where they cross, and then your double congruent to the right and the left on the other one. So we need 2 congruent marks. And then lastly but not leastly, Jack C, who's going to read the last one.
If one pair of opposite sides of a quadrilateral are congruent and parallel, then it's a parallelogram.
Okay, so this one's the tricky one. So draw your parallelogram. If one pair of opposite sides are congruent and parallel, then it's a parallelogram. All right, let's look at some applications. So let's decide using our theorem if there is enough information to call this guy a parallelogram. So we have this shape here. It's got congruent sides that are parallel. Can we call it a parallelogram? Okay. I'm going to exclamation point that. Okay, so B, we have 2 pairs of opposite congruent sides. Which theorem does that go with? If any at all. They say it's 8. Let's look at our picture. Yeah, 6.8. So we're going to go parallelogram. All right, C says my opposite interior angles are congruent. So we can use that information to show what? If opposite interior angles are congruent, then lines are parallel. If opposite interior angles are congruent, then lines are parallel. So what? So my lines are parallel. Does that give, is there any theorem that says if your 2 lines are parallel, then you have a parallelogram? What other piece of information did we need to make this a yay? Yeah, we would probably need like that the sides are congruent?
Or the other two lines.
Yeah. So, not enough information. Nay. That's what I will say. Nay. I say nay. Not enough information. Okay. So, I have got two parallel lines and one pair of opposite sides. If one pair of opposite sides are perpendicular and parallel, they're not the same. It's not the same. The same lines have to be congruent and parallel. So I say, nay. Not enough information. Has to be, so the congruent marks have to be on the same marks, same lines as the parallel. All right, what about this? Consecutive angles are supplementary and opposite angles are congruent. Can we call this a parallelogram? Si, senor. We say parallelogram. Which theorem are we going to use for it? See which one matches. Both pairs of opposite angles of quadrilateral are congruent. Let's use the supplementary one. Let's go 6, 9. All right. Oh, Nelly. Okay, so we're going to plot these 4 points on our graph, and then we're going to show that we have a parallelogram. And we, to show that we have a parallelogram, we're going to pick a theorem, and then we have to, if we pick a theorem with lines are parallel, what do we know? Lines on a grid that are parallel have what property? Same slope. Okay, and then Nick, if my lines are congruent, if my side lines are congruent, then what formula do we usually use on a grid to do the distance of a line? Yeah, the distance formula. Not your question. So if we're proving that our sides are congruent and we are not laying flat on where we can count the boxes, we're going to have the distance formula. If we're trying to prove lines are parallel, then we need to find the same slope. Just so that you guys know what your future holds. Okay, let's see if I can graph these correctly today, since my struggling graphing is happening. So we go over 2, down 1, and that's A. And remember, we draw the point, we put the letter and the coordinate on with it. B is 1, 3. C is 6, 5. And D is 7, 1. Alrighty, so we're going to get a straight edge and we're going to connect these guys together. And unfortunately, they do not rest on any of our horizontal or vertical lines. Well, step number 1, it looks like a parallelogram. I don't have any information on angles here. So any of my formulas that have angles in it, I can't use. So that automatically eliminates 6, 9, and 6, 10. So we can go both pairs of opposite sides are congruent, or we can go one pair of opposite sides are congruent and parallel. I think this would be the easier calculation than finding the distances of all 4 sides. This one we find the distance of one side and the second side. And then we find the slopes of one side and the final side.
Why don't we just find the slopes of all the sides? They're parallel.
So do we have a property that said you need 2 pairs of parallel lines? Do we have a property that says that? That's a good question, Jeff.
No, there should be.
Oh, darn. Okay. So
Draw one in there.
so we are going to try to follow theorem 612, where one pair of opposite sides are congruent. So 612, we need a pair of congruent sides, and then we need a pair of parallel sides. And it needs to be the same one. So don't switch sides on me. Okay. So I'm emotionally connected visually with BC and AD. So I'm gonna, because it's oriented the way, like BC feels like the top of the parallelogram to me, and AD feels like the bottom of the parallelogram to me as well. So I'm gonna find, let's prove them parallel first. So I'm gonna find the slope of BC, and we take our y values and we subtract them. So that's 3 minus 1. And we take our x values and subtract them. So that is 1 minus 6. Hold on, where's my 5? Let's try this again. What I get for not writing it down. x2, y2, x1, y1. Slope is y2 minus y1 over x2 minus x1. Okay, y2 is 3. Y1 is 5. X2 is 1. X1 is 6. Okay, thank you, Lily. 3 minus 5 is negative 2, and 6 minus 1 is negative 5. So the slope of BC is 2/5. Take a moment to double check I did that correctly. Let's find the slope of AD, and if I play my cards right, then they are the same slopes, and we can show it's congruent. So AD is y2 minus y1 over x2 minus x1. Oh, thank goodness. Negative 1 minus 1 is negative 2, and 2 minus 7 is negative 5. That is 2/5. So we have the same slope. We are parallel. So go ahead and mark those lines. Boom, boom. Parallel. Done. So we did this. Now we need to show that they're congruent. We're going to do that by using the distance formula. And we go x's subtracted and squared. And y subtracted and squared. And so I'm going to find the distance of BC. Already written on my graph which one's my x1 and y1, so easy peasy. That is 6 minus 1 squared and 5 minus 3 squared. 6 minus 1 is 5. 5 squared is 25. 5 minus 3 is 2. 2 squared is 4. 25 plus 4 is 29, so the distance is the square root of 29. Not even a calculator. What's up? Booyah, mental math, y'all. Okay. So the distance of AD, we're going to find in the same way. We're going to take x1, which is 7, minus x2, which is 2, square it, and y 1, which is 1, minus -1, and square it. 7 minus 2 is 5. 5 squared is 25. 1 minus -1 is 1 plus 1, which is 2. 2 squared is 4. (25) plus 4 is 29. We know that the distances are both square root 29. And so BC is congruent to AD. And by theorem 612, A, B, C, D is a parallelogram.